So if we think about reciprocal graphs as 3 steps. Step 1, draw the original graph that was on the bottom. Step 2, do all of your asymptotes. You have vertical asymptotes at x-intercepts, and you have a horizontal asymptote at y=0 if your graph went up forever to positive infinity or negative infinity. And then step 3, just do some nice points. Because all that's going to happen is your y value gets changed to 1/y. And with this, we can now graph things that we never graphed before. And this will be a little review of chapter 6. So if you were wanting to graph cosecant of theta, well, the reciprocal steps say, hey, first draw sine of theta. That's what would be on the bottom. And then do all of your reciprocal steps. Nice points, asymptotes from there. So to save you some time, I already graphed sine of x. So now we have to go through the process of graphing a reciprocal. After this is graphed, step 1 would be asymptotes. Do we have any x-intercepts? Yes, lots of them. We have, I'm feeling a little bit bad that I graphed so much of sine x, because we're going to have to draw dotted lines for a while here. So wherever there is an x-intercept, we are going to get an asymptote. And there's lots of them. Do I draw an asymptote at y=0? No. Because my graph doesn't go up forever. So there's our asymptotes. If you wanted to, look, I'll label one of them. This one's x = pi. You could label them all if you wanted. Next, do we have some nice points? Well, if we think about sine, here you would have pi/2, 1 on your sine graph. And on your cosecant graph, that 1 would change to 1/1, which would be exactly the same. So I'll label that in green, I would have that same point. I can think of, for example, from your pi plate, which you do have to have your pi plate memorized for your exam, so that's another thing that you have to make sure that is ready to go. They'll give you a little mini unit circle that you can fill out at the beginning of your exam. Sine of pi/6 is 1/2. So if the rule is that all you do is the reciprocal, or 1/y, well, the reciprocal of 1/2 is 2/1. That would be on your cosecant. And you actually had enough information to draw that already, because you know it has to go towards the asymptotes. 1/, graphs have no x-intercepts. And we can do all of these points. Wherever it's -1, 1/-1 would stay the same. And this green graph is your cosecant graph. So we do our asymptotes wherever we have x-intercepts. We find some nice points, and then just have to draw things towards our asymptotes. So I'm going to get you to do the secant graph on your own. On the next page, you have the secant graph, and then we'll get to the little bit messed up cotangent graph. talked about why cotangent is a bit messed up. Not too bad, but just a bit. But let's see how you did on secant. Did you get asymptotes? At each of the exits. And then wherever you have 1, 1 over 1 would stay the same. So these will all be the same. And same thing with -1. Those will all be the same. And then towards the asymptotes, and there you have your graph of secant. Now the reason the cotangent one is a little bit strange is because mathematicians had to make a decision. They had to decide if they should use cotangent equal to 1 over 10 or use cotangent equals to cos theta over sine theta. And they're very similar but have a tiny little difference. Okay? Tangent has some values that are not allowed. You are not allowed to do tangent of pi over 2. It's undefined on your unit circle. So if we were doing cotangent as 1 over tangent, you would have some values that are not allowed. Pi over 2 is allowed in cos theta over sine theta. So what mathematicians decided to do, dealt with the asymptotes of tangent. Okay? And if you would go to your calculator, I'm going to pull up my calculator here. My calculator doesn't have a cotangent button. But we're going to check what happens if we did, right? If I do 1 divided by tangent of pi over 2, and I guess I have to be in radians to do this. If I do this, my calculator says, error, that's not allowed, because you're not allowed to do tangent of pi over 2. Okay? Let's quit that and say that's nice. But if I went and did cos of pi over 2, divided by sine of pi over 2, because that's also cotangent, I get 0. So now the question is, what did mathematicians decide for cotangent? Is cotangent pi over 2, are they going to say it's equal to tangent of pi over 2 and be undefined? Or are they going to use that it's equal to cos of pi over 2 over sine of pi over 2 and decide it's equal to 0? And they decided to use the cos of pi over 2 divided by sine of pi over 2, or in the official definition of cotangent, that's what would happen. So we're going to have to use that in our question. First of all, wherever you have x-intercepts of tangent, you will have asymptotes for cotangent. This graph is going to start to look very busy. That's why I printed it out on your paper for you. Oh my goodness. So many asymptotes. I shouldn't have gone to 4 pi. I should have just went from negative 2 pi to 2 pi. So we've drawn our asymptotes. Normally, tangent goes to infinity. So normally you would draw an asymptote at y equals 0. But because mathematicians have decided to use cos of theta over sine of theta instead of having that asymptote, we have x-intercepts. Wherever tangent had an asymptote, we have x-intercepts. A very nice point to have used on your original graph would have been pi over 4 comma 1. Because if you did the reciprocal, you would get 1 over 1. Does it make sense that wherever your graph, so we would have that point on our cotangent graph as well. In fact, wherever your y-coordinate is 1, cotangent would be the same. Can you see that that would also be true wherever your graph is negative 1? If it's negative 1, 1 over negative 1 would stay the same. So I've got a bunch of nice points. And after you have your asymptotes and your nice points, your graph is going to go through your nice points towards your asymptotes. And so on. So your cotangent graph looks almost identical to a tangent graph, just as going the other way. And it has x-intercepts where your tangent graph had asymptotes. Because officially, this is how we graph. That is the official cotangent graph. The official graph of 1 over tangent would look the same, but instead of x-intercept has holes. It would have a hole at every exit. At every actual x-intercept of cotangent, the 1 over tangent graph would actually have holes, because that would be a non-permissible value. Those are tiny little details. Yeah, I can say in the past 20 years, there's been like only twice a cotangent graph has showed up on an exam. Not very often, but it has happened. So, right? If I had to bet this time, I would say no, I don't think it. I don't think it'll be a cotangent graph. Then I would have lost a bet 1 year. It has been on there. So it is a possibility, but the idea is you graph it like a 1 over tangent graph, but then you add the x-intercepts in. Normally on a reciprocal graph, if your graph goes to infinity, you would have an asymptote at y equals 0. This is a special case where that doesn't happen. So with these, we are done our reciprocal graphs. I'll stop our video.